Okay, we're going to start 5.7 here. Nice thing about 5.7 is it's a wrap up of all the things that we've done so far. So we're going to start with a couple examples and lead to some discoveries here. Pick 2 points on the line y equals 2x in the first quadrant and find sine of theta and tangent of theta if theta is the angle made with the x-axis and the line y equals 2x. Well, first thing we need to understand is that this is our angle theta that we're talking about. Okay, and if this is the line y equals 2x, I'm going to pick 2 different points. We'll start with the first one here, and this is to prove a point later on, but this is 3, 6. Okay, now if we want to evaluate sine of theta, what we first need to do is find the hypotenuse of this triangle. Here we have this is 3 and that's 6. We need to figure out what the hypotenuse of our triangle is. We'll call that little r. So quickly here I'm going to do, using Pythagorean theorem, I'm going to say r equals 9, which is 3 squared plus 36, or r equals the square root of 45, which equals 3 square roots of 5 if you reduce it. Okay? Once we have that, we can say, alright, then the sine has to equal 6 over 3 square roots of 5. Or we reduce 2 square roots of 5, 2 over, the square root of 5, and by rationalizing that, okay, we end up with 2 square roots of 5 over 5. So that's the sine of our theta. The tangent of our theta equals opposite over adjacent, which in this case is 6 over 3, which ends up equaling 2. Okay? Now, just to switch it up and to prove a point here, I'm going to pick another point. So let's just pick 5 and 10. 5, 10. That's on the line y equals 2x. And we create another triangle here. Now this time, the green side here is 5 and the y component is 10. And we need to know now what our bigger radius is. So I'm going to use capital R just to distinguish between the small radius and the large. And this one, by Pythagorean theorem, is going to be 25 plus 100, or the square root of 125, which turns out to be 5 square roots of 5 if you reduce it. Now, if we look at sine of theta in this case, you'll see that here we'll have 10, which is the opposite of the angle, over the hypotenuse, which was 5 square roots of 5. And if we reduce that, we get 2 square roots of 5, and if we rationalize that, we get 2 square root of 5 over 5. Notice, these are the same. Okay? And if we take the tangent in the green circle of theta, you'll also find that this is 10 over 5, which equals 2. Okay, this drives home a point that's real key to this section, which is it doesn't matter where you pick a point on this line, the triangle that you create is going to be similar to other triangles that you pick that would be constructed if you picked any other point on that line. So it doesn't matter what point you pick, the trig ratios will be the same, the ratios of the sides, because the triangles are similar. So from there, what we actually figure out is if we define r to equal the square root of your x coordinate plus your y coordinate squared, then we can define the 6 trigonometric functions on the coordinate plane in the following way. Okay, sine is going to be y over r, cosine will be x over r, tangent will be y over x, cosecant will be r over y, which is the reciprocal of sine, secant r over x, and cotangent x over y. Okay, it's worth noting here that r will always be greater than 0. It's a distance, so it's always positive. That's going to be key. X and y, however, could be positive or negative based on what quadrant they're in.